Hello, in this video we're going to go over a problem from Virginia Tech Regional Math Competition in 2011. And this is about evaluating an integral. We are going to use a technique called limit swapping for integrals. And this technique allows us to do a change of variable in a way that the two limits of integration are going to be swapped. For example, if you take u equals 5 minus x in this example, when x is 4, u would be 1, and when x is 1, u would be 4. This change of variable is not a very good fit for this problem because that changes x to 4 minus 5 minus u, which is not a very good change of variable. So it looks quite different from the original integral. What other u substitution can we use in order to swap the two limits of integration? The best one for this problem appears to be 4 over x. When x is 1, u becomes 4, and when x is 4, u becomes 1. And that easily swaps the limits of integration. It's a multiplicative u substitution, which fits really well into this problem. So let's now do this change of variable and see what we get. So let's start with doing a u substitution. U equals 4 over x. So this gives you du equals negative 4 over x squared dx, which is negative. If you square u, you get 16 over x squared, and divided by 4, you get 4 over x squared. So this tells us dx is negative 4 du over u squared. Now we are going to substitute into the initial integral. We get the integral from 1 to 4. X is 4 over u minus 2, 16 over u squared plus 4 times square root of x, which is root 4 over u, dx, which is negative 4 over u squared du. Now, and this is the initial integral. So if I clear the denominators, I'm going to get 1 to 4. 4, I can factor a 2 from the top. I get 2 minus u on top. And I'm going to factor a 4 from the bottom. I get 4 plus u squared at the bottom. And if I multiply the u squared through and the u through, I would get 2 root u. And then there's a minus 4 du here. If I and by the way, the original limits of integration are going to change to 4 to 1, because when x is 1, u is 4. When x is 4, u is 1. Now I'm going to take the negative sign and then flip the limits of integration. Simplify, you get the 2's cancel, the 4's cancel, and you get 2 minus u over 4 plus u squared root u du. Okay, so this might seem kind of redundant because it looks like we got the exact same thing that we had, although not quite. So if you think about what we had, so what we showed is that the integral from 1 to 4 of x minus 2, if you go back and see what we had x minus 2 over x squared plus 4 root x dx is equal to, I'm going to change the variable to x. I'm going to change u back to x just so that these two are going to look like the same. Okay, so these two are negative of each other. So that's negative 1 to 4 x minus 2 over 4 plus x squared times root x dx. So this integral is negative of itself. Therefore, the integral must be 0. So the integral from 1 to 4 of x minus 2 over x squared plus 4 root x dx is in fact 0. And that is our final answer. If you liked this video, make sure to subscribe to the channel where you can find more videos like this. And you should be able to see videos like this on the screen. Click on one of those videos. I have other videos discussing limit swapping technique with different types of transformations. Click on one of those videos and I will see you in the next video.